Okay, we are live.
Hey, hello everyone, and welcome to the December edition of the audio programmer Meetup. Thanks for tuning in and joining us today. I've been off for a couple of months. I've been moving house and I've been over at ADC giving some workshops. So I'm really glad to be back with you. And as you might notice, I'm in a different setting. I moved out to the south coast of the UK, down near Hastings. So if anyone's ever in the area, please feel free to reach out and I'll give you some recommendations for this stretch of coast. Be great to have you. And so tonight we have two amazing guests, both guests with lots of experience in audio signal processing. We have Jatin Chowdhury and Daniel Strubig joining us tonight, and we're really looking forward to both of their talks. Before we get started, I'll thank our sponsors. They are Focusrite, Sonox, and JUCE. Thank you for your continued support and allowing us to do this every month. Josh, how's it going tonight?
Yeah, everything's great. Everybody else seems to be in cold weather, but I'm down here in Florida enjoying some sun. So, yes, I'll try to soak some sun rays for everybody if you're in a cold place. And I hope that everybody is staying warm and safe and gearing up for the holidays. And just wanted to remind you about our audio programmer community on Discord. So it's a great place to do some coding while you're getting ready for the holidays and wrapping your Christmas presents. And join us on Discord. We have developers from all around the world, all different skill levels. And you can join us on theaudioprogrammer.com/Discord. And we also have a wiki now that we've started. And so some people have been very nice enough to uh, give and provide some of their learning lessons along the way as they've been learning about audio programming and JUICE and digital signal processing. And you can check that out at wiki.theaudioprogrammer.com. We also have some job opportunities that are out there. So for people who are not aware, we also do recruitment and contracting of audio developers to some of the best audio development companies in the world. And if you want to find out about our job opportunities, head over to theaudioprogrammer.com and we have some opportunities. And with that, I'll go ahead and I'll pass it back to Rachel to introduce our first speaker.
Sorry, give me 1 second. I've just lost my screen. There we go. I'm back. I was on a different screen. I can find my way back to the unmute button, but I'm here now. Yes, so I'm going to go ahead and introduce our first guest speaker this evening, and that's going to be Daniel Strübig. And Daniel is an R&D engineer at Jabra in Copenhagen. He's originally from Germany. And tonight he's going to be speaking about audio quality prediction, if I remember correctly. And that's going to be a Rust-flavored introduction. So I'm really excited to know exactly what that's going to entail. And I think we're going to split the talk into, is that right? We're going to have some of the talk and then some questions and then the second half.
Yeah, that would be the preferred way for me. I think it's best for everyone instead of me cramming up the whole content into one bit, and then all of a sudden we have to start answering questions that were answered half an hour ago or something. That's something I would not prefer to do. Is it okay if I just start sharing my screen, or anything else you want
whenever
to say?
you're ready.
Cool, perfect.
Go ahead. Thank you.
Okay. So let's hope this all works out. Let's see. Okay. So I will go here and I'll go back to my keynote. So yeah, thanks Rachel, thanks Josh, thanks Jatin, everyone for organizing, and everyone in the chat or on YouTube sort of attending this or watching it afterwards. So yeah, my presentation is sort of like one of my attempts to work on my New Year's resolution for 2022 and sort of start presenting a bit more of the stuff that I've been doing sort of in my spare time. And actually getting it out there and sort of start sharing information and maybe inspire other people to see what they've come up with, given the information I provide. So the topic I'll be talking about is sort of speech quality metrics. You could replace the word speech with audio, but I find that they're very difficult to get out of my system simply because I work with speech signals basically every single day. So if you ever hear me say speech quality prediction, evaluation, or metric, they all sort of mean the same thing. And then the second part, I will sort of get a bit into the Rust flavored bit and just sort of share some lessons that help me sort of pick up a new, rather complex language, basically while having a day job, something that's can be challenging at times. And I just hope that inspires some of you to learn and to grow as developers. So Rachel introduced me previously, but I would just like to sort of repeat who I am. My name is Daniel. I grew up in Germany. I've been living in Copenhagen, Denmark for a little over 4 years now. I currently work as an R&D audio engineer at Jabra in Copenhagen in Denmark. So very much involved in sort of research and development for anything DSP related. Specifically, I work in a small team that works on speech enhancement, so things like noise reduction, voice detection. I have a fair bit of experience with deep learning in that space, and also sort of speech evaluation and speech quality. Speech quality in general. On the right, you can see me standing at Aachen Museum outside of Copenhagen, pretending that I understand art. I'm a frequent ADC participant, so if you're somewhere in the audience and you find me sort of vaguely familiar but can't really put me in a context, I've been a very frequent audio developer conference ADC participant. I've also been the guy who's been working on Soul tutorials in the years 2020 and 2021. So if you've seen these videos, then that's really cool for me to know. It's a great time working on these videos. Previously, I had a career in location sound, film and game audio design, and also the bits of game audio programming. I have a degree of Masters of Science in Sound and Music Computing from Aalborg University in Copenhagen. It's an education that basically focuses on DSP development, the underlying math and the software development aspect of things for these applications. Before I venture into the whole topic, I would just like to give an overview of what Jabra is as a whole, because sometimes people cannot really locate the name of the brand. So just to give you an overview of what I'm sort of concerned with, the company that I work in, sort of in my day-to-day life. So Jabra itself is a brand that focuses on sort of business headsets, speakerphones for meeting rooms, sort of meeting room video and audio solutions. Jabra itself belongs to a bigger corporation within Denmark called GN, and GN is a big sort of roof corporation for many other brands, and that is actually a very interesting field to work in. So there are basically 3 pillars here. The sort of medical side of things. So there are many medical brands which produce headsets for hearing aids for hearing impaired people. So who work on technology for that. Then there's also the space I've just talked about, which is mainly Jabra, which focuses on sort of enterprise solutions. Jabra also has a strong position in the true wireless market. So anything like miniature earbuds that you use on your daily commute to and from work, for sort of canceling outside noise and listening to your favorite podcast. These are also products that Jabra produce and that I'm personally heavily involved with in developing. And lastly, there's also a company called SteelSeries, which is producing sort of gaming headphones, earbuds, speakers, and also things like keyboards and mice. So it's a very sort of colorful bouquet of audio brands under that roof, and it's so far it's been leading to very fruitful collaborations to have sort of various fields of expertise under one roof. It's really nice. It might be a bit different. I think usually on Josh's channel there are it's a lot more about sort of DSP sort of plugin development, and also sort of user interface development. So here everything is it's a bit of a different domain, but the paradigms are definitely similar that we work with in our day-to-day jobs. So without further ado, I'm going to talk about speech quality metrics, a very term that doesn't sort of roll easily off the tongue, but I'll try to explain it sort of as beginner friendly as possible and sort of try to eliminate all the expertise and all of the implied knowledge that I have and simply say, okay, how would it work? How could I explain this the best way possible if somebody without the knowledge that I possess were to learn about these things. So I'm just going to start off with an example that as an audio developer you are hopefully familiar with. So let's assume you have the following situation at hand. You have some input signal. It could be single channel, it could be multi-channel. We can disregard that for now. And you run that through some type of processing step. So what you end up is with some type of output signal. Again, mostly mono-channel. Could be multi-channel. But this output signal is what we are going to concentrate on for the remainder of this presentation. And it's really about the qualities and the features that make up this output signal. So here I've listed in this processing step, I've listed a couple of things that could happen that I'm personally very much concerned with, and everyone else who works in the sort of communication industry and on that type of signal processing is heavily involved with. So it could be any type of data compression. You could be working on a communication client, such as the one we're using right now, such as Zoom. Could also be Microsoft Teams or WebEx or any other communication client here. You could be applying some noise reduction, so you end up with a potentially enhanced signal in the sense that you've reduced noise that you didn't want to pass through. But at the same time, it could be that you've degraded the speech signal along the way, because in the end, these are things that are difficult to separate overall. It could also be that you work on a codec or something else. For any types of speakerphones, you would need something like an echo canceller if you have a microphone that's sitting right next to a loudspeaker. Oftentimes you cannot simply get away with it, but you need to make sure that there's very little from the loudspeaker leaking into the microphone. So let's assume that you have this step. So you have an input signal, you have a processing step, and you have an output signal. And you want to assess the qualities of that output signal. So that's the situation that we're dealing with, basically. And you want to know, question you want to answer is sort of how faithful is my output signal? So this guy right here, how faithful is that to either my input signal, if you want to sort of preserve as many qualities as you possibly can, or, and I hope that is easy to wrap your head around, some known signal that you sort of desire to achieve. So it could be some enhanced version of a signal that is known. that is known to you. One example could be if you have a recording of a speech signal without any noise, and you run a noisy signal through this processing step, how faithful are you to your original speech signal? So that could be one of the use cases. And then the other question you want to ask is sort of how would another person or a set of persons, the aggregate of multiple opinions, rate the quality of my outputs? And that is, I hope that this becomes clear, is that we are mainly dealing with sort of qualitative measures, either the terms of distortion or the terms of sort of bandwidth limiting you've introduced in the processing step right here. So these are the questions that we basically want to answer, and I hope that is somewhat clear. So what are your options, right? I mean, since we're all audio developers, that's we can of course start listening, and I would say yes, this is your pair of ears is the most valuable tool that you have in your at your disposal, and it's a crucial and it's a valid step, and you could probably go ahead and sort of rate that on a scale. Here I've introduced a scale from 1 to 5, so 1 being extremely bad and 5 being the best you could possibly imagine of your output signal having the quality that it needs. But you could probably argue that you would want more than one opinion, and also that the opinion that you get should be somewhat statistically valid. I'm not going to go into the whole sort of statistical analysis of things, but what you could do, and what is also very, very essential and crucial thing to do, is you could conduct a subjective study. So you simply start asking people, scale from 1 to 10. Sorry, on a scale from 1 to 5, how would you rate the quality of my output signal? But these things, they are, in my personal opinion, they are well, maybe not expensive to make, but they at least they take a lot of time to make. Subjective studies are very, very difficult to get right and to really nail it. You would need to remove as many variables as you can from your listening test. And lastly, they simply take a long time to conduct, to analyze, and to also conclude the results. And oftentimes in early stages of algorithm development, that you might be more to sort of leaning towards the side of how can I get opinions quickly, or how can I get an assessment of quality quickly. So let's park all of these things to the side for now, and let's say, okay, if you want to have something fast that is not your own opinion, but would simply sort of approximate the average listener, and an assessment of that. So we can keep some definitions, and we are going to define what we otherwise known as a MOS scale. So MOS stands for mean opinion score. So it's basically the sort of the average rating of an average listener to a degraded signal, and we can define that scale from 1.0, which is extremely bad, to 5.0, which is extremely excellent. Best of all worlds. Thank you very much. And then the output signals of our algorithm are rated on this scale from 1 to 5. And just to make things a bit easier for us, we can safely assume that a difference of 0.1 on that scale is just noticeable. So if you have two signals, one is rated 2.2 and the other one is rated 2.3, the average listener would be able to discern these two signals and say that there is a noticeable, albeit just noticeable, difference between these two signals. It's all very researchy, it's all very nerdy and very academic, but I hope you can sort of bear with me here, and maybe in a minute start seeing all of these, like the beauty that's underlying in this machinery. So basically, what we need is a machine that's given a process signal or output signal and a known desired signal. It computes a score on the scale that we've defined earlier, with 1.0 being extremely bad, 5.0 being the best you could possibly achieve. So we have these two signals, and then we have this I've called a speech quality predictor right here. And this speech quality predictor will simply take all of these signals and tell us what is on a scale from 1 to 5, how would an average listener possibly rate this? And I hope that this makes sense. And if this known desired signal is a bit unclear to you for now, I will explain it in a second from now. So in essence, this is what audio qualities predictors do. You have two signals. One is the signal that you want to achieve. The other one is that you can produce right now with the algorithms that you have at your disposal. And these quality predictors, they simply take these two signals and say, okay, we have some assumptions about the average listener and how that average listener would rate that. And we are simply going to output a score. So I would like to demonstrate that with an example of one of these quality predictors. One of these is called Viscal, developed by Google. And just for completion here, there's a multitude of these metrics out there, with potentially of various amounts of use cases and specialized and trained towards sort of different degradations and different types of signals. So the audio file that I will play back is basically a person saying, "The birch canoe slid on the smooth planks." Don't ask me why. I don't know to which degree that person is into canoeing or into smooth planks. I really don't know, but it's a sentence from a very canonical set of sentences that were developed many years ago, which in combination are what's called phonetically balanced. So all phonemes of the English language are sort of represented equally. It's a very nerdy way of thinking about languages, but let's stick to that for now. So I will switch off my my keynote right here, and I will switch to Audacity. Josh, we made it work before we started the live stream, so hopefully this is all gonna go well.
My fingers are crossed.
Yeah, mine too. But let's look at two different signals here, and these signals I've taken them from a test set of the speech quality predictor right here, which was developed by Google. So let's take this reference signal right here, and I will start playing that 2 times. And I would just like you to like everyone to sort of memorize what are this what are the key features of this. So I will just start playing this back 2 times, and I'll also shut my mouth.
The birch canoe slid on the smooth planks.
Did everyone hear everything? Did it go through, Josh?
Yes.
Okay, I'll play 2 more times. Okay.
The birch canoe slid on the smooth planks.
And I'll play it 1 last time.
The birch canoe slid on the smooth planks.
So this is one of I would argue female talker. I would assume female talker saying this sentence right here. Well, we can then, if we take that as our golden reference and we say, okay, this is the best we could possibly achieve, but in order for an algorithm or a solution to work, we need to compress the signal, not in terms of loudness or volume, but simply in terms of information. We need to reduce the amount of information that's in there. And let's say we do this, we come up with something clever. Oh, as the people at Google they came up with something clever. And then we run this through our processing step, and we we end up with a degraded signal. So I'm going to play this 2 times again, and then I will play the reference signal 2 times again, and then I will play the degraded signal 2 times again. Okay, just so you can understand some of the key difference between the reference signal and this degraded signal right here.
The birch canoe slid on the smooth planks.
And I'll play it again.
The birch canoe slid on the smooth planks.
And I will play the reference signal again.
The birch canoe slid on the smooth planks.
And again.
The birch canoe slid on the smooth planks.
And then finally, I'll play the degraded signal again.
The birch canoe slid on the smooth planks. The birch canoe slid on the smooth planks.
So there are some subtle differences. And I hope this all, that the processing that was introduced by teams while we're on this call hasn't been diluting the differences too much. But you could possibly hear that, especially the sort of S sounds, and also some of the vowels, they tend to be a bit distorted or a bit sort of filtered, if you will. And just to illustrate this, I will just switch both of these signals to a spectrogram view. So basically, you still have a timeline on the x-axis, and then the y-axis basically represents the frequency bins that we are concerning with, and then the color or the intensity of each of these lanes, if you will, they represent how much energy there is in a certain frequency bin. And if I also switch the degraded signal to a spectrogram view, then you can see that basically most of the information in the high frequencies, sort of above 4 kilohertz, is completely gone. So we can see that there is a significant degradation, and if you were able to hear that, then kudos to you. Great job. So that's what we can do, right? And now we want to see, okay, given this is the output signal we produce, how would an average listener sort of rate that from 1 to 5? And what you can do right here, oops, I should have probably cleared my command line, giving away too much, is we can simply start launching this out. Now it's called Visco, what the RS stands for, we'll get to in a second. But usually these come as sort of command line executables, many of these algorithms. And what we can do is we can start giving it some command line flags. If you're not too familiar with the command line, I'm sorry if I'm losing you here, but yeah, that's I think you might be able to read up on what these commands actually and how a command line works afterwards. So we give it a flag called reference file, and this is just a path to the reference signal that I've showed you earlier, and then we also give it a degraded file and a path to that degraded file right here. And what we basically get is we have an input of two audio signals, one desired one and one that we can currently achieve. And we basically get a single number out in the end. And I will also use this use speech mode flag right here, basically to tell the algorithm to tell the predictor that this is a speech signal we're dealing with. And if I hit enter, it's going to take a small while. And after some other text right here, we actually get this MOS that I've presented earlier. And we get one of 2.3994454, whatever. 2.4. So we are roughly halfway where we could potentially be. And this just goes to illustrate sort of how these speech quality metrics work. And I hope that you're I haven't lost you yet. But so this is what audio quality predictors do, and we've just looked at an example of speech which has been band limited after some processing step, and this is what they do. So the other thing, and then this sort of reference signal comes into play. There are going to be some more definitions that I would just like to add for completion. Is that the known desired signal, so what you want to achieve, is usually called a reference signal. Reference is signifying, you know, that sort of an upper bound that you could possibly imagine to achieve with a certain processing step. And then there are metrics which require a reference signal, and these are called intrusive metrics. So intrusive meaning we need to have some insight of what's the best possible thing we can achieve, right? It's basically, how can I put this the best way? It needs to have a certain, these predictors, they need to have a certain a certain sense of information of what is the optimum that we could possibly achieve in order to maximize the full potential of this scale from 1 to 5. Otherwise, you would start, it would basically clamp at 1.0. It would start clamping at 5.0, and that is not really insightful. But there are also metrics which do not require a reference signal, and these are called non-intrusive metrics. So they basically have an innate sense, sort of a inbred sense of knowing what good and what bad is, and they do not require sort of an upper reference right here. And also, lastly, just to drive this home, is that most, if not all, predictors work on a full audio file and not on a single block that you could fetch from your audio card or from your audio device. Because usually these things they sort of integrate over time, and all of these evaluators they look at a longer audio signal that's longer than a single block of data that you could fetch from your sound card. So it's full audio signal in and then a single number basically out. So that's that. There's an overview. I've provided you here with an overview of what's out there basically. This is of course an incomplete overview because I'm not aware of anything and everything that's going on in this field of research. But there are things like Polka, Pesk, 3Quest. You might be starting to realize that there's a Q in all of these abbreviations, and usually this signifies some sort of quality. So every one of these metrics is looking for some type of quality in a signal. Viscal is the one I've demonstrated, and I'll talk about later as well. There's a metric called STOI, which focuses solely on the sort of intelligibility aspect of speech. There are many aspects to speech, and sort of looking at it from different angles. And intelligibility is only one of the many dimensionalities of that. There are things like ambiqual, which look at sort of, I think, binaural signals and their qualities. And then lastly, there's this differentiation I've made between intrusive metrics and non-intrusive metrics. So DNSMOS, developed by Microsoft, by Russ Kotler, and many other of the researchers at Microsoft, which basically made a model, a deep learning model, which sort of has this innate sense of what a good audio file and what a bad audio file is. And there's also Niska from people at the University of Berlin in Germany, which can achieve similar things. So there's a whole plethora of metrics out there that could potentially help you with achieving what you need to achieve in any type of communication product or other solution or software. So you might be wondering by now, what you could use it for. And I've listed a couple of sort of use cases right here. So there are things like regression testing, where you sort of have multiple versions of an algorithm, and you want to see sort of how they evolve over time, how you can whether or not there is an actual improvement. That I mean, your ear is one source of evaluating that, but these these predictors could be a secondary one. You could potentially integrate it into your continuous integration or continuous development. Many of these predictors, they come as a command line executable or a web service. So it should be hopefully not too big of a pain to integrate them into CI or CD pipeline. And then what I've alluded to earlier, it's simply a good assessment during sort of the early stage development of an algorithm, and sort of validating a potential improvement. So is the improvement that you hear with your ears, is that reflected by, you know, a secondary pair of objective ears, if you will. And lastly, I mean, you tell me. This is, prefer this to be a dialogue, right? So if you would say that that there is a use case that I've overlooked, or simply haven't come across just yet, then I'd be happy to engage in a dialogue and see what's out there. So how should you view these metrics, right? There's a certain sense of perspective that I would just like to provide here, and that is, of course, you can be it might be easy to get complacent and to say, okay, this well, what the metric is saying is what the metric is saying, and that's the ground truth of everything. So these evaluators, these predictors, they I would definitely not consider them as the sort of the truth, whatever that means. And it definitely does not replace sort of thorough listening and training your ear. And I would actually argue that yeah, what I said earlier is that your pair of ears is the best tool in your arsenal that you have. But what I will say is that these evaluators, they are a good, I would say rather inexpensive perspective on how an output signal of let's say a codec or some type of data compression, how that output signal sounds to an unbiased and to an objective listener. I'm very much not free of sort of taking ownership and taking pride into the work that I do, but that also comes with a certain sense of bias. That I might be things that I might be hearing things that I want to hear. And so putting these into perspective and sort of a grander scheme of things, it's a very healthy thing to do on a regular basis. These metrics, they are a very, very vibrant topic of research, and I would say that both the need for these metrics and also the sort of the emergence of deep learning neural networks have definitely helped in this topic of research. So definitely keep an eye out and choose these metrics wisely in case you ever attempt to introduce them to your tool chain or to your production chain. And lastly, which I find very, very just a very beautiful thought, is that it's a possibility to describe the quality of audio signals, which I find an otherwise pretty difficult thing to do. There we come up with a lot of terms like warmth, like clarity, sort of, it could be boominess, or any other thing that you could think of to describe an audio signal, which I think is a difficult thing to do, because what does that really mean to every individual of us? So having something like these evaluators in your tool chain, they can definitely help shaping your perspective, and also help shaping your listening and your ear. For the avid listener, there's a very good sort of online discussion on the Danish Sound Cluster.dk, which is an organization that sort of facilitates meetups for people in the audio industry in Denmark, which is surprisingly big. You wouldn't believe it for such a small country. But in this whole topic of perceptual audio evaluation is very, very vibrant. and it's definitely ongoing. And with that, I would just like to simply take a break, see where we are time-wise. Oops. And maybe take 1 or 2 questions in case there are any. If there's anything that's open for discussion. Josh.
So at the moment, we have one question from
Yeah, for sure.
from Paulo Chiliguano, who
Okay.
asks, "Is mean opinion score relevant?" I'm not sure if you.
Mean opinion score. Yeah. I mean, yeah. I mean, in the end, it's up to you. I can personally tell you that these things are rather interesting for us as engineers. I think everyone in the field of communication industries would definitely say that, yeah, they are important. They are not by no means crucial. I think in the end, a well-shaped ear and a sort of having an ear for detail and degradations. That's the determining factor. But it really helps getting a perspective on things. Yeah. And also I think the fact that it's been a very sort of emerging field in research. There must be a demand for these things. And the fact that there are many publications, especially in recent years. I would, from my point of view, yes, they are relevant. But you can feel free to disagree, of course. Yeah.
Great. We have another question from George,
Mm-hmm.
and this may go into what you're about to present here in a minute.
Okay, yeah, for sure.
The question is, how easy is it to develop an audio quality metric? Does it take a research team, or can one person do this?
Yeah, it's if you want to develop your own metric, you mean, for your own use case, yeah, it's yeah, I would say it's a rather difficult thing to do. Most of these metrics, they have a lot of sort of nonlinear steps involved, such as a deep learning model. And I mean, the easy trap that you can fall into is that you can overfit to a certain set of input signals. And then if you give it something that it hasn't seen before, it will simply give you a random like a random score back. And these things I've said earlier how important they are in my day-to-day work, but ultimately it's a mixture of both your own listening and your own hearing and what these metrics are telling you. And if you feel like there's a big sort of disconnection between these things, then you might want to evaluate this again. But long story short, I would say, yeah, it's not very easy to come up with these metrics, and they need to undergo very rigid evaluation. Yeah.
Great. I think that's all the questions for now.
Cool. Yeah.
Please continue. We're curious to hear more.
Can you follow, Josh? I hope it's not too deep down the gutter with the things that I'm doing.
No, I think
Okay.
I think it really, from my interpretation, it comes down to taking our interpretations of what we hear as sound being better or worse, and posing the question, how do we develop algorithms that are able to do the same thing? Am I
Exactly.
right?
Yeah.
Yeah.
That's essentially what's going on. Yeah. Cool. Great
Yeah.
validation. Okay. So that's the sort of first half. I hope I can speed things up ever so slightly. So let's continue, and let's have a reset, and let's park everything we've learned earlier. And let's talk about Rust. And this is also the part of the talk where I will get a bit more sort of subjective and personal, and tell some personal stories that I've experienced throughout the course of this year, at the sort of soul the whole conundrum of speech quality and its evaluation is sort of a segue into that. I will also say that if you're learning, if you're completely new and you say, oh well, this is finally the moment where somebody will explain Rust to me in its great length and detail, then I'm sorry, I won't be showing too much code or too many examples. But this is rather a sort of subjective story, and I would also say there are many learning resources out there which do a tremendously better job than I could ever do in trying to teach you that language. But in case I'll try to get everyone on board here, and in case you're not familiar with Rust, that's a perfectly valid thing to do. But let me just get over some facts. So if we simply go to rustlang.org, then Rust itself is describes itself as a language empowering everyone to build reliable and efficient software. Rust stages itself as a general purpose language, and its main features, I would personally say, is that it's statically and very strongly typed, and a strong type system is a big ally when writing Rust. It has no interpreter. There are sort of intermediate representations, but there is no bytecode involved, and everything that you get after compilation is pure machine code, basically. One of the key differences that Rust has compared to other languages in similar sort of general purpose domain is that it does not rely on manual memory management, such as in C, or a garbage collector like C#. And the instead, what Rust decided to do is that it enforces very strict rules at compilation time. It does that by utilizing a mechanism that was developed called the borrow checker, and with this paradigm of looking at what variable owns what, so looking at ownership, and also looking at how things are referenced, and in which way they are referenced. So either with read access or write access, otherwise known as mutably or immutably. It can basically enforce very strict rules at compilation time, which whenever you try to do some dodgy stuff or try to access memory that would be deallocated otherwise, it will simply say, I will not let you compile this. The compiler can look ahead in time and simply say, here are some suggestions for you, but right now what you're doing is dodgy. Please fix it. And it's a very good recommendation to play ball with this. And I of course don't mean that in a limiting way, but rather in a sort of in an empowering way. It also has an extensive tool system called Cargo for managing dependencies, generating documentation, sort of executing unit tests, sort of figuring out what functions are actually tests and which ones aren't. And so it focuses a lot on sort of developer ergonomics and seems to do quite a good job at achieving this. So if you talk about some hard facts, then usually some anecdotal truths are not far off. So I can again, I've mentioned that this talk will become a bit more subjective now. And I can personally tell you that while learning Rust, which I've been doing for a bit over 1.5 years now, is that I've started to, after a certain while, to start feeling a strong sense of accomplishment when writing Rust. The compiler, as strict and as no as it is, actually turns out to be your ally. It has some very strict rules on how you manage memory. But again, if you play ball, if you follow what it's recommending you to do, it starts nudging you in the right direction. And it's not so much about sort of limiting in the way that in the things that you can do, but rather you need to apply different paradigms of thinking coming up with a solution that you've made. So in short, what I've started to sort of experience that when writing Rust is to put it personally, I can start to focus on the what, so actually implementing stuff, and the how, sort of how to design things. They sort of start falling into place, and they might not be necessarily optimal, but they will get the job done for you fairly well. After some practice, of course. There's no free lunch. But I can also tell you that learning Rust is definitely not easy. It's still a challenging thing to do. And that is just a good reminder, maybe for everyone. So saying that, just enforcing here that basically none of the stuff that we're doing is trivial, and it's probably the reason why many of us who work in this domain professionally have a master's degree, if not a PhD, and multiple years of academic experience. So this is far from trivial, anything that we're doing. Lastly, Rust is fast, and I would say that's what we need here. What I've implemented is not it is it is not bound to any sort of real-time constraints. I've sort of deliberately shied away from that, but it would get the job done for sure. And so computing such a score, such a mean opinion score, is it doesn't need to be real time, but it shouldn't be completely slow either. It shouldn't take forever. And just what I've referenced here is like one of these papers called Energy Efficiency Across Programming Languages, where a set of researchers, mainly from Portugal, sort of took a look at different languages and started looking at if we implement the same the same piece of instructions across different languages. How do they perform in terms of energy consumption, in terms of time it takes to complete, and also their memory consumption? And this is a very interesting paper to read, I would say, to choose what's in your arsenal, basically, to choose the tools that you need to choose. So how can we marry these two things? And this is again sort of a personal journey here. Is that how did I learn Rust? And so far, I think you may have recognized my enthusiasm for any type of speech quality evaluation. And this sort of, I tend to look at these things a lot, both within work but also outside of work. And what I decided to do is, in order to tackle this task of learning Rust, is I simply looked at what's out there, and I rewrote one of these evaluators. So the specific one that I rewrote is called VSQL, which is an abbreviation for Virtual Speech Quality Objective Listener. Rolls easily off the tongue. And yeah, it's been developed by Google and the University College Dublin, in Dublin in Ireland. There are some great scientific papers on the whole development. If you just type in Google VSQL in your favorite search engine, then it will spit out a multitude of different papers which go into the depth of how the score is actually being computed. And yeah, also just to stress this, so this whole metric is something I personally didn't come up with myself. Like all of the iterations that went into the actual algorithm, that was mainly done by the people Jan Skoglund, Andrew Hines, and Michael Sheenan. Hope I'm pronouncing that correctly. So I'd just like to say a special thank you to them, and also that the idea is not mine, but I've simply taken on the challenge of rewriting one of these in Rust. So what does it do, practically speaking? Well, what is it I actually did? Is I simply studied the C++ code base. I definitely have a fair bit of familiarity with C++. I took a look at the C++ code base and the conference papers I mentioned a minute ago. The C++ code base is fortunately, it's fortunately it's of very, very good quality, and it's very well tested. It has a build system that doesn't make you pull your hair out on a Tuesday afternoon at 8 p.m. or something. But it's it compiles nicely. Like the tests are very, very transparent and very thorough. And the way I went about it is I studied the C++ code base, the conference papers, and I wrote the corresponding tests and the implementation in Rust. Simply translated it one by one, and sort of did a rinse and repeat until one test succeeds, and then the second test succeeds, and then as you keep chipping away, as you keep working, all of a sudden you find yourself that all of the end-to-end tests they also succeed, and that's what I basically achieved. To give you a bit of perspective on this timeline, this is something that I did entirely outside of my day job. I started in January of 2022, again as a sort of New Year's resolution, start early. And I wish I could give you a better approximation. I think I spent maybe 2 hours per day. So, if the sun was out, I didn't spend any time. If it was raining, I spent 3 or 4 times working on that project. And I had my first sort of successful integration test, or successful end-to-end test in June of 2022. And what I've been doing ever since is sort of cleaning up, documenting, and eliminating errors that basically previous Daniel has made. And it's this sort of very cathartic feeling of looking at code that you've written maybe only a couple of weeks or months ago, and then immediately looking at it and saying, "Oh, I wish I would have had all of the knowledge that I possess now." And that sort of iterative cycle, that's ultimately very cleansing, in my opinion, to do. So I've also basically demoed it earlier. I don't know if you can see this, but this is basically this Viscal sort of -rs is basically saying, okay, this is something I've done myself, and this is the sort of Rust implementation of things. And it's basically it does the exact same thing as the other executable does that was written in C++ years ago. And you might say that, oh well, that's not very innovative, Daniel. But I would just like to stress sort of why working that way helped me in becoming a better developer, and also sort of making things easier for me. So I would just like to sort of muse a bit about the beauty of simply rewriting stuff that already exists, simply in a different language, and simply for learning purposes, and with no sort of financial or other constraints in mind. So the beauty of rewriting a library that already exists is that it ideally the library that you take as a reference is something that exists already. Again, ideally, should be tested. Please write your tests. But what they do is, personally, what I can tell you is that I've often as the tests that were already existing, they served as some type of validation step in the implementation that I've made, and basically gave me this sort of rope to cling on to during development. It's also the simple fact that the idea itself is already there. And I would definitely say that I am a creative person myself, and I can definitely find ways to solve problems creatively, or to make my own pieces of creation. But both coming up with an idea for what to write and learning a new language, that is something I would say is can get pretty difficult to do, because it starts becoming some type of chicken or the egg problem. If your idea is not well defined, which it might very well be, then picking up this language is also not becoming any easier. And again, Rust has a lot of complexity, and I would say that combining these two things, if you can pull that off, then I mean, you have all my due respect. But personally, decided to choose a different gateway into the language. So probably the biggest insight that I got at the end of this project was sort of seeing how paradigms can be transferred from one language to another. And I would say that's been the biggest learning experience for me personally. It's a simple way that you know, in the end, programming languages are a tool to solve a certain task. And if you look at things like how Rust achieves polymorphism using trait objects, or sort of how to basically look at a V table in runtime and see and knowing what the correct entry to choose is something that it just gives you a fresh perspective, both if you are a seasoned C++ developer and also if you're a seasoned Rust developer. It's a very good sort of way of sort of cross-pollinating your own knowledge, if that makes sense. To simply say, okay, so you have similar paradigms. How are they achieved in two different languages? I will end with some practical stuff. Some of the libraries that helped me get started. So what you could see earlier is, of course, I wrote a sort of command line executable, and there are various different sort of problems to solve in this. So anything from argument passing to reading a WAV file to performing an FFT, to handling errors. The libraries that were used in the C++ repository are this Upsile library by Google. I find it a very interesting library, but which solves many of these sort of argument passing and sort of defining relationships between arguments for a command line executable. The equivalent for that, the crate, that's the terminology in Rust for library, is called CLAP, stands for command line argument passing. It's a very, very well used and well adapted library with great support, and takes a lot of headache away from you. There's Hound for WAV file reading, which is something you pretty much always want to do. There are many very good, very, very performant FFT implementations. And then one of the many beauties of Rust, I would say, is that error handling is actually part of the sort of core and standard library. And I've talked about this very strong typing aspect of Rust earlier. And basically, you can encode all of your error handling as sort of custom errors that you define and that you raise throughout the logic of your application. So lastly, hopefully this concludes my talk. Yeah, probably. I would just like to sort of share some of the things that I've learned myself. Sometimes the hard way, sometimes for seeing it. And that is when you're trying to learn a new language, I would say try to sort of reduce uncertainties as much as you can during the course of your application. So I've deliberately chosen a command line executable to implement because they are, I would say they are slightly more predictable than anything that involves a graphical user interface. They're of course less shiny, and it's not as easy to show off your command line executable to someone. But I think it's a very sort of forgiving gateway to learn a new language. Then I would also say embrace ugliness, or sort of embrace that things are work in progress and sort of ever evolving, and the pace by which you learn the language and all the various aspects of it. They also start to dictate how sophisticated your implementation will be, but simply embrace that it won't be perfect on the first try, and be forgiving to yourself. Also take baby steps, and what has helped me personally is to start writing down your achievement. So anything counts, really. It could be anything from today I learned how to implement the plus operator on a type in Rust, or it could be I learned how to write a unit test. I learned about the macro system. I learned about how trade object works. So the smallest achievements, they matter. They end up they add up. They add up for sure. And also do not be afraid of using libraries in the beginning. I very much deliberately made the decision to say, okay, I don't need to write everything from scratch here. And very much learning a language involves learning libraries and how they work, and studying these is a very good gateway to see how you could potentially improve your implementation. I also try to sort of reduce unnecessary complexity. Of course, unnecessary is very subjective here, but especially real-time systems. I can speak for myself here, but they are definitely a pain to get right. And there are many sources of error lurking pretty much anywhere in the sort of peripheral chain. So I deliberately said, okay, if I free myself from any sort of real-time constraints and simply, start small, then that is definitely a better gateway into learning a language. Give yourself time is something I would recommend. And also lastly, abandoning a project, abandoning writing a solution is always an option, and it will definitely not eliminate what you've learned along the way. All of these things are uphill battles, and if you choose something that's where you feel interested in, or you are interested in, such as for me it was this whole speech quality, speech evaluation thing, and then by all means try it. And if you start losing interest, if you start losing time, then abandoning it or calling quits is always an option, and there are only things to gain in either of these decisions that you make. So yeah, that was my advice that I've just personally learned over completing this. Where are we with the slides? Yeah, that's about it. Thanks. If you want to get in touch, I think LinkedIn is the best thing the thing that I mostly respond to. I've put my profile right here. But if you start just looking for my name, there aren't many other people with that name and in the domain that I work in. So I'd be happy to engage in a dialogue either about Rust or about this whole quality evaluation conundrum. It can also be a controversial topic for sure. Oops, those were played. It can be a controversial topic for sure. But I'm just happy to hear if there's anything you've learned from this talk. And with that, I think I'll stop sharing my screen now, and see if there are any other questions or any other feedback that you have, Josh or Jatin or Rachel.
Yes. So great talk, and thanks for sharing your experience about Rust. Really
Thank you.
interesting to hear your experience about porting a library to another language. And there are a couple of questions.
Oh, here we go.
George has asked if you happen to know if there's a Rust equivalent of the C++ Boost library.
Oh boy. No, but that's simply the fact that I've touched Boost, but I've never I've personally never used it in any sort of major production or anything. So it would be very difficult for me to even assess, what's in Boost that is not in the C++ standard library. I don't know. It depends on the problem that you're trying to solve. Sorry, that's the best answer I can give.
Okay.
Yeah.
Great. So Quacks BK said, great talk. One thing that you
Thank you.
implicitly endorsed is test-driven development, which is incredibly helpful in developing any application.
Yeah, thank you.
And George also says, I rate this talk 5.0. Excellent.
Cool. Wow. Well, that's definitely a meta joke right there. Kudos to you, George. Wish I would have come up with that.
So QuacksBK had a question of
Yeah.
what's your favorite Rust feature or improvement over C++? He is guessing, or she is guessing, the
Hmm.
build/package system. What
Um,
do you feel?
yeah. It's a very difficult question. I try to stay, I try to stay as sort of unpolitical as possible for this, and I know that there are also, entire sort of discussions about why one language is better than the other. I don't think there's a better or worse. It all depends on the things you're trying to solve, and the essentially in the end it's a tool and it generates machine code and or what. I can personally say that yeah, the package managing is great. It's sublime, especially compared to a code base that doesn't use CMake. I think CMake has come a very long way in sort of facilitating facilitating build processes, and sort of taking away all of this extra sort of headache that you need to go through sometimes. I think the biggest advantage of Rust is that it has very little sort of historical heritage, right? For C, sometimes C++, it even has to support the architecture that's on my grandma's first calculator or something. Or what do I know? Some really old sort of architectures, and that's something that Rust doesn't need to have. So it can be a bit more sort of it can be a bit more flexible and sort of sometimes dropping features or introducing new features without having this backwards compatibility. So that also makes its disadvantage, right? It's still young, it's still new, but
Yeah.
that's okay. That's something I can live with. And otherwise, the whole macro system, is it's sometimes it's complete magic, and the code it's generating for you, and all of the headache that it removes for you. I've alluded to this clap crate earlier, which does a lot of the command line passing and sort of generating all of the help output for you. The option and the result types are great for handling errors. It's completely exception free. The the way you sort of the ergonomics of things, the fact that you can that you have access to sort of views into arrays. It's similar. I think C++ has a similar like an equivalent with it now for STD view or something it's called, but where you can sort of take a glimpse into a range of an array, and you don't need to think about a raw pointer. Is a great. It just frees up so much of the mental the sort of the things that I need to think about, and I can focus on the what and not so much on the how. So it's a bit of an elaborate answer. Hope that's fine.
That's great.
Yeah.
So it looks like that's it for questions. Thank you very much, Daniel. That was a great
Cool.
talk.
Yeah, thank you so much. Thanks for having me. It's been
Two for the price of one.
for sure.
Yeah.
Cool. With that, I'll start muting myself. Maybe we can take over to Jatan.
Yeah.
And yeah, otherwise, if you feel like getting in touch or something, just hit me up on LinkedIn. And yeah, sometimes I'm a bit slow at replying. Hope that's okay. Okay, I'll shut up now. Thank you, Josh.
Cool. All right. So now we have our next presenter, Jatin Chaudhry, who is a DSP engineer who has done quite a few open source things on GitHub. So make sure you check out Chow DSP, and he's going to talk about a alternative to the JUCE's audio processor value tree state class, a class that everybody knows if you've ever built a plugin, and everybody loves or hates. And I'm very curious to hear this talk. So take it away, Jatin.
Yeah, thanks, Josh. Here, let me share my slides here. Where to go? All right. Let's see if I can share the whole screen. Perfect.
And I will also link to these slides. Do you want me to link to them now or afterwards? I don't want to
Sure, now it's fine, just in case I guess anyone wants to follow along. Yeah, so the slides are all online, so you can follow along at home, or if you want to come back to them later, they're all here. So yeah, thanks Josh for the introduction and everything. So yeah, I'll be talking about replacing the JUCE audio processor value tree state. So I guess this is probably going to assume that hopefully you've seen some JUCE code before, so at least you kind of have the flavor for what it looks like and feels like. And yeah, there may be a bit, there may be a few parts that go a bit deeper into C++ than maybe some people are familiar with, but hopefully if there's anything that's confusing, we can catch that at the end with questions and things like that. So yeah, this is me. Right now I'm based in Seattle, Washington, and do freelance audio development. Before that, I was at Karma for a little while, and then I worked at Tesla for about a year. And I spend most of my time just making plugins, and a lot of them are open source. So if you want to look at the code, they're all there on those links. And yeah, so I understand why JUCE named this class the audio processor value tree state. I think it's a good name, but it's kind of hard to say when you're talking about it a lot. It's a lot of words to say. So I'm just going to shorten it to value tree state or VTS. So if I use either of those words, just know that I mean the audio processor value tree state. But I didn't feel like using all of the words. So yeah, when I started writing JUCE code, maybe this was 2015 or so, not really many people were using the value tree state. I think it did exist at the time, but I didn't really see it used commonly until maybe 2018 or 2019 or so. So I wanted to give a little flavor of kind of what code looked like in the time before the audio processor value tree state. So this is kind of a sort of a simple example plugin that you might have. And so in your plugin, maybe you have a few parameters. So you have maybe a float parameter, a choice parameter, and a Boolean parameter. And so you would create these just as raw pointers in your plugin class. And we're going to make them null pointers so that they're not uninitialized. And then in our constructor, we'll create the parameters. And we're going to do this for now with the new keyword. And I know you're not supposed to do that, but I kind of wanted to use that specifically to show a point, which is that there's kind of this weird thing with parameters in JUCE where you have to create them yourself, but then you don't delete them because the plugin will delete them. So it's kind of this weird thing where I have to use new to create it, but I don't call delete because the plugin will call delete for me. And then if I were to use something like a standard unique pointer or something like that, then that would cause other problems because then the unique pointer would delete the parameter and then the plugin would try to also delete the parameter. So then you would get like a double delete thing, which can be kind of weird. So next we would call add parameter, and this will add the parameter to our plugin. And so now the plugin is kind of the owner of the parameter and will manage all of the deleting and stuff at the end. And then maybe we need to do some audio processing. And in the audio processing, we need to know the values of these parameters so we can do it just by calling get or get index, depending on what type of parameter it is. So this is maybe not too complicated, but what's kind of interesting is that as we try to do other things with these parameters, it gets a good bit more complicated. So let's say we want to save and load the plugin state. So if you want to do this, you have to get all of your parameter values and then store them in some format, maybe like XML or something. And then when you want to load the plugin state, you get the values back from your XML, and then you set the parameter values. And this works fine, but it gets a little annoying because whenever you add a new parameter, you have to add a couple extra lines of code here to manage that. And, you know, hopefully if you forget that, you have plugin val or some other kind of automated testing thing that will kind of catch you. But even if you have that, you can run into an issue where maybe you add a parameter and then someone tries to load a plugin state that was saved with an old version of the plugin, and you have to make sure you're handling that case correctly too. So, you know, none of this is crazy complicated. People were doing it, but it's just a little bit annoying to have to go through every time. And then we get to the UI code. So let's say that you want some knob or slider in your UI, and you want to connect that to a parameter. So to do that, you would have to do something like this, where you create your slider, and then you create a slider listener. And then whenever the slider value changes, you have to update the parameter. Whenever the slider starts being dragged or whatever, you have to begin or end your change gesture. And this actually isn't even a complete implementation for linking a slider and a parameter, because we're not handling parameter changes that could come from things other than the slider. So maybe there's host automation, or maybe there's a preset change or things like that. And we would want our slider to change its value for that as well. And we're not doing that currently. So as you can imagine, that's kind of a lot of code. And then you're repeating that code for every single slider, every single button or whatever that you have in your plugin. So that ends up being quite a lot of UI code that, it would be nice if there were a way to not have to write all of it. So that's where the value tree state comes in. So we're kind of going to go through the same exact example, just with the value tree state now. So when you create your plugin, it's basically the same, except that you now have your value tree state instance in your plugin. And then you've got these parameter handles, which are these atomic float pointers instead of your old parameter types that you had before. Then I'll make a function to actually create the parameters. You can do this without a function too, but I think it's a little bit cleaner to do it with. So here we'll create our 3 parameters, and we can do them as unique pointers because they'll get released later on anyway. Then we go ahead and create our parameters and put them in the value tree state. And now we can get our parameter handles and work with them however we want. So this part looks more or less the same, but now when we go to save and load plugin state, we just have this pretty much cookie cutter code that I copied from the JUCE tutorials, and it'll work for you. Hopefully just out of the box, you won't need to do anything different or change anything. And then for your UI code, you have these slider parameter attachments or combo box parameter attachments or other types of parameter attachments that will take care of all that UI glue code for you. And now, your UI code, which was maybe 100 lines before, is now maybe, I don't know, 20 lines or something. So you can write your UI code in a way that's much, much neater. So just to kind of recap, when you start using value tree state, you get state, saving, and loading basically for free. You get undo and redo basically for free. I haven't talked about that, but you can do an undo redo manager in JUCE and hook that up to your value tree state, and it's pretty easy to do. And then you get these parameter attachments, which will push your UI component actions to your parameters and update the UI components when the parameter changes because of some external change. And I think I should also mention that as of JUCE version 6, you actually don't need to use the value tree state to get the parameter attachments. Prior to JUCE 6, you did need to do that, but I guess now you don't. So you might be looking at this and saying, well, the value tree state seems to make everything, a bit nicer. So why would you ever want to replace it? And if you're asking this question, maybe you don't need to replace it. So the value tree state is actually pretty good at what it does. And maybe as you've seen, things were generally a bit worse before the value tree state existed. So if you're thinking about doing this, just know that you might not need to. The value tree state does its job pretty well. And really, there's just a few kind of smaller things that were my reason for trying to, do my own thing. And also, I guess maybe I like the challenge or something. So yeah. Anyway, a few things that I don't like about the value tree state. First is what I call strong parameter types, which I'll demonstrate in a second. Second thing is that there's parts of using the value tree state where it's not very clear which threads certain bits of code will run on. And this can cause some problems, which again, I'll show you in a second. And then finally, there's one spot where JUCE does something that I'm not convinced is real-time safe. And we'll talk about that in a second as well. So what I mean by strong parameter types is, let's say that you have the same kind of example, but now instead of your atomic float pointers, you want the actual float parameter type, because maybe you need some information from it that you can't get from the plain float pointer. So if you want to do this, you have to do these dynamic casts. So instead of calling your get raw parameter value or whatever it is, you have to call it get parameter and then dynamic cast that parameter to your parameter type. And this isn't so bad, but it's kind of annoying because it's like, well, I just made this parameter. I know what type it is. Why do I have to dynamic cast to get back to the type that I just created? So that's a little bit annoying. And then the annoyance gets compounded just because dynamic cast can be a bit expensive. And in a case like this, where maybe you're just doing all those dynamic casts at initialization time, it's not too bad, but it's still a little bit annoying. And then maybe you say, well, if you know what type it is, why don't you just reinterpret cast? And I guess you could try that if you want, but I wouldn't recommend it because if you try to dynamic cast and you get your type wrong, then you get a null pointer and it's pretty easy to debug what's going on. If you reinterpret cast and you get your type wrong, then you'll get what your C++ program will think you have a valid pointer to your parameter type, but in fact you don't. And then you can get all kinds of weird bugs that might be difficult to track down. So maybe don't do reinterpret cast if you can get away with dynamic cast or whatever you're using in that situation. So then this idea of thread clarity comes up. So this is probably something that a lot of folks have run into, where maybe you have some UI component and you want that component to disappear when some parameter is changed. So maybe you'll write code like this, where you have a value tree state listener, and then when your parameter changes, you can go through and say, hey, if it's this parameter, then change the visibility of my component. And the question that I'm going to ask is, which thread is this code going to be called on? And the answer is that it could happen on the UI thread, or it could happen on the audio thread. The UI thread case will usually happen if the parameter change came from the plugin UI. The audio thread case will usually happen if the host automation caused the parameter to change. And then you'll get the callback maybe on the audio thread. And what's kind of frustrating to me is that the JUCE documentation for the value tree state doesn't mention this. If you do a bit of digging, you can figure out that the value tree state listener is actually using a audio processor parameter listener, and the documentation for that does mention it, but you have to do a bit more digging. And that's kind of annoying because I feel like this is some code that it seems like the obvious way to do things. And it turns out to be wrong, but you may not know that it's wrong because maybe you're only testing your plugin in the standalone version, and then you don't have the case where your parameter change could come from host automation because you're not in a host. So it's kind of this sneaky bug that you wish the documentation or something like that would stop you from doing, but it doesn't seem to do that. So anyway, then maybe you say, well, okay, why don't I just use a parameter attachment for that instead? Because with a parameter attachment, I know that the callback for my parameter attachment will always happen on the UI thread. And in that sense, you're right, that will happen, that will be the case. But if you want to look at how the parameter attachment actually gets that to happen on the UI thread, this is the code that does that. So basically, your parameter attachment is a parameter listener and also an async updater. So when the parameter value is changed, the parameter attachment will check if you're on the message thread. And if you are, then it'll say, okay, call the listener right away, or call the callback right away. And if you're not on the message thread, then it will trigger an async update. And then when the async updater runs, then that will cause the callback to be called. So the question is this trigger async update function real-time safe? Because that's going to get called potentially on the audio thread. And according to the JUCE documentation, it is not real-time safe. So the JUCE documentation says it's thread safe to call this method from any thread, but beware of calling it from a real-time thread because it involves posting a message to the system queue, which means it may block. So that's not good news. And if we look at the implementation, we can actually confirm this. So if you dig kind of far down through the call stack of trigger async update, eventually you'll get to this function. And in here, we see that we are posting a message to the system queue. And that's where we run into behavior that may not be real-time safe. So that's a bit annoying. So now I was going to talk about my implementation for something that I've been starting to use instead of the audio processor value tree state. And I guess before I do, I should mention that pretty much all of the code that I'm about to show you is stuff that I started writing maybe like 2 or 3 weeks ago. So it's just been a little bit of hacking that I've been doing. So I'll mention this more at the end, but some of this stuff is still a little bit rough and still going to get hopefully improved over the next couple months as I keep working on it. But I should also mention that there was a lot of work that I did before I started working on this, which actually made some of this process a bit easier. And that's kind of what this slide is about. So there's a few things that are kind of important for the implementation that I'm about to show. So one is that there needs to be some way of serializing the data. And this is just for saving and loading your plugin state. So JUCE likes their value trees for this, and the value trees do a good job. And the value trees map very well onto sort of the XML way of storing data. But maybe you would want to use JSON or some other format. So it'd be nice to be able to, switch between different formats. And kind of something that goes along with this idea of serialization is this concept of reflection, which I'm not going to go too deep into now, but there is some parts where I'm using reflection to make this work. And the way that I do it is I use this boost PFR library and also this name of library. Don't be too scared of boost PFR. You can use it without boost, which is what I do, because yeah, boost is pretty massive. So maybe it's not something you'd want to bring into your project just because of how big of a dependency it is. But yeah, PFR can be used on its own. I also had implemented some custom parameter types. You don't really need to have these for what I'm about to show you, but there's one spot where it makes things a little bit nicer. There's also a lock-free queue that I'm using. There's a lot of good implementations of that out there. The one I'm using here is the Moody Camel reader-writer queue, but if there's another one that you prefer, that would probably work just as well. And then there's also a few spots where you need kind of this broadcaster-listener pattern. And JUCE has a way of doing this with their listener list, but I found this library called Rocket, which I think I like a bit better. It's got some nice benchmarks and things like that. And just sort of a slightly different way of organizing things, which I think I like better. The one thing I don't like as well is that they name things like signal and connection and things like that, which can be confusing when you're also working on an audio application. So I renamed a bunch of their classes to things like broadcaster and callback and stuff like that, which you'll see in a moment here. So when I started working on this, I was kind of thinking in this way where I was like, well, why can't we just do it this way? And so this is something that Eyal Amir showed me, maybe a year ago with some of his code, where he was like, well, what you would want to do is just have sort of a struct of parameters, and then the parameters would live in your plugin. And then when you need to access a parameter, you just go to the parameter like that. And I guess I think Eyal had some code that worked this way, and I could have asked him to borrow it or something, but I wanted to try to figure things out for myself. So that's kind of where the rest of this is going to come from. And the reason why you can't just do this as the code is written here is because the JUCE audio processor needs to own the parameters. So because this float parameter here is like a local variable, it's going to get deleted when the parameters struct goes out of scope. And so when the JUCE audio processor tries to delete the parameter as well, then you're going to get your double delete problem. So you can't do this directly, but there is another way that we can kind of make this happen. So first, I had to create this thing called an optional pointer. I'm not crazy about the name, but I haven't thought of a better one yet, so that's what I'm going with for now. And the idea here is that you've got 2 pointers. So you've got this owning pointer and you've got this non-owning pointer. And basically, when you create the pointer, it's an owning pointer. So you say, okay, I'm going to do make unique to create my object. And then I'm going to set the non-owning pointer to also point to that object. And then maybe at some point along the way, I want someone else to become the owner of this object. So then I can call release, and I can use no discard to make sure that someone else actually uses the value that gets returned from this function. So now the owning pointer is null pointer, but the non-owning pointer still points to the same data. So this is kind of handy. then I can use my custom parameter types to, give them this little type alias. So I can say, okay, I want a float parameter pointer to be an optional pointer to a float parameter. And now I can do basically the same thing that I was doing before in the very first example I showed, the pre-value tree state example, where I just go through and call this add parameter function for all of my parameters. Except now I need to do it with this release function. So after I call release on the parameter holder, it will still point to the parameter. It just won't be the owner of the parameter anymore. So I can create this plugin state, which is what I'm going to call my value tree state replacement. So plugin state is parameterized on this params type. And then I can create the params locally and add them all to the processor like this. And then when I want to actually create my plugin, I can do something basically like this, where I create my parameters in a struct just the way I wanted to before. But now I'm creating pointers instead of just the parameters themselves. Then I can create this plugin state object, which is using this parameters type. The state lives in my audio processor. And then when I want to do something with my parameter, I can just access it pretty much directly like that. So that's kind of a nice thing. And I think I'm still getting used to writing code this way, but I think I like it a bit better overall. So now, why can't we just have parameter listeners that work maybe a little bit like this? So we have our UI component, and maybe we want to have this UI component also be a parameter listener. So we say, okay, I want my plugin state to add a listener. It's going to be this. It's going to be listening to this parameter. And I want the callbacks for the listener to happen on the message thread. And then in my param changed method, I can say, hey, if the parameter is being changed is this parameter, then I'll change my visibility. And I know that this is always going to run on the message thread because of this argument that I passed here. So the reason why we can't do this with the value tree state listener is, first of all, because when the listener is called, the parameter might not have changed yet. So when we override value tree state listener, we also need to have this argument for the new value of the parameter, which might not be equivalent to the value that I would get from like calling get on that parameter at the same time. So in order to kind of make that work, you kind of have to have that extra field to make sure you're getting the most up-to-date version, the most up-to-date value of the parameter. That's a little bit annoying, so maybe we'll see if we can work on that. Another problem with the value tree state listener is we can't specify which thread the listener is going to be called on. So that's a little bit annoying, but again, we'll see if we can work on that. And then the third issue is that this code is actually incorrect. And the reason it's incorrect is because we never remove the listener from the plugin state when the UI component is deleted. And this is a kind of silly bug that I've run into probably at least like 20 times now, where like you do something like this and you test it again in the standalone version of the plugin and it works fine. And then maybe you test it in a DAW and it works fine. And then you test it in a DAW maybe like a week or two later, and you open the UI and you close the UI and you open the UI again. And now you get a crash because you have a dangling listener from the first version of the UI that you deleted previously. So yeah, that's kind of a silly bug that's unfortunately like a little bit weird when you're trying to test to, like, you'll run into that bug at weird times and not necessarily when you're looking for it. So it would be nice if there was a way to prevent that bug before it happened. So again, we'll come back to that in a second. So this is the way that I've been working on implementing listeners for my plugin state. And the way I'm doing it right now is I have this JUCE high resolution timer. So this is a timer that will run on a background thread. And then again, I have an async updater, but we'll be using it in a little bit different way, which you'll see. So then I have these param info structs. And in the struct, there's a pointer to your parameter, which I'll call the cookie. And there's the most recent value of the parameter. And we'll see why this is useful in a second here. So then I need to count how many parameters I have in my plugin state. And something that's kind of nice is that this is actually known at compile time because of well, it's kind of tricky to make this happen, but you can do it at compile time. And so then you can have an array of param info objects. You can also have an array of broadcaster objects. These are broadcasters that are going to broadcast whenever the parameter changes. And we can have message thread broadcasters, and then we'll also have a set of audio thread broadcasters. And then we'll need this queue. And the point of this queue is basically to pass these messages between threads. So when we need a broadcaster to run, we'll have to pass a message from the high resolution timer thread to whichever thread the broadcaster needs to run on. And then that's going to make it happen. So this is where kind of the nuts and bolts of the implementation are laid out here. So first, we have to go through all of our parameters and create a param info object for all of them. So we just initialize them with the parameter pointer and the initial value of that parameter. Then we start our timer, so that's not too bad. And then in the timer callback, we go through every single thing in our parameter list, and we check if the value has changed. And then if the value has changed, then we can queue up a message to say, hey, trigger the broadcaster for this parameter on the message thread. And then we can use trigger async update to basically make that happen. And actually the trigger async update is real-time safe here because we're not, or it doesn't matter if it's real-time safe because we're not calling it on the audio thread, we're calling it on the timer thread. And then finally, in our async update handler, we can just run all of our message thread actions. And you can imagine basically the same sort of thing would work for the audio thread version of the broadcasters, except that we would have to run them on the audio thread instead of on the message thread. So that's kind of the idea there. Then in our UI component, we can set up our listener this way. So we have this scoped callback object. And the idea with the scoped callback is that when it goes out of scope, it will delete the connection between the callback and the broadcaster. So we know that when the component is deleted, that the connection will be destroyed as well, and we won't have the dangling reference problem. So then when we create our listener, we say, hey, I want to listen to this parameter. I want to listen on the message thread. And when the parameter changes, I want to do this. And now we can just get the parameter value directly instead of having to get a value from the function or anything like that. And again, this is kind of a nuts and bolts thing, but this is what's actually happening when we add the parameter listener. And one thing that's kind of important to point out is that we can mark this function no discard. And the idea there is that if we forget to attach a scoped callback object to whatever thing is returned from this function, then we'll get a compiler warning. And that again is useful for avoiding that dangling reference issue I had mentioned. So it's kind of nice because something that previously would have been kind of a sneaky bug that we only would have found through a certain type of testing is now something that we'll get a compiler warning for. And we know that we'll be able to catch it that way. So I should mention that this is probably the part of my implementation that I'm the least sure about. So I'm pretty confident in the real-time safety. I think that the code that I've been writing, sort of the client code that I've been writing to work with this way of doing things, ends up a little bit neater than it was with the value tree state. However, it seems a bit wasteful to create a new timer thread for every plugin instance. So like you can imagine maybe you have a session with like 200 plugins and maybe each plugin has its own background thread for doing this. Might not be the most efficient way of doing things. So maybe we could use like a time slice thread and share that between every instance of the plugin. Maybe that would help a little bit. Maybe we could just use a regular timer and have all this stuff run on the message thread. That's an option too. So that's something that I've been thinking about, and I'm just going to have to do some testing and see what seems to work the best. And then the other question is, what if the plugin is being used in like an offline rendering context? So the issue there is that the audio processing might happen much more quickly than the listeners are getting called. And so if the listeners aren't getting called quickly enough, things might not update in time, and you might get some weird behavior in the offline rendering. So in the testing I've done so far, this seems to be okay, but this is something I need to test with maybe a much bigger plugin than I've tested with so far, because I think that's where we might run into issues. So yeah, I'm still making sure that this is going to work, but yeah, we'll see what happens. And then finally, we say, hey, we want our parameter attachments to be real-time safe. Well, now we can do that with basically the same parameter listener method that we just walked through. So again, you have your scoped callback, and when you create a parameter listener, you set it equal to the scoped callback. We tell it, hey, we want this always to happen on the message thread. And now we can get parameter attachments that are basically the same as the JUCE parameter attachments, but now they've got some improved real-time safety. And so, yeah, this is what it looks like in the sort of in the UI code. This is another kind of neat little trick that I figured out. So maybe we have some sort of nested parameters. So we have our parameter struct, and then we have a struct inside that struct, and that's the one where the parameter lives. So what we can actually do is make this little string-like parameter path. And the idea here is that we have the name of the struct and then the parameter ID. And that gives us the parameter that we're looking for. And it's kind of cool that this works, but I'm not sure I'm going to keep it in there just because I feel like it's going to lead to just magic strings everywhere and very messy code. So yeah, I'm probably going to get rid of that, but it's kind of cool that we can do it at all. So I was kind of happy that I got that to work. So finally, I just wanted to give a simple example of maybe a very basic plugin that uses this system. So maybe you've got a plugin and it has 3 processors that are doing things internally. So here's our processor 1, and it has some parameters. And so in the processor, we can have the parameters struct as a reference, and then we can initialize it in the constructor. And then when we want to make our whole plugin, we say, okay, well, let's make the parameters for each of the 3 internal processors. Maybe we have some other state. So this is a stateful thing that's not a parameter that we would want to save with the plugin state. We can do that too. I haven't really talked about that, but that's not too difficult. And so now you've got your plugin state, which has both the parameters and the non-parameter state. And then you create your processors. And when you want to initialize your processors, you can just do it like this, where you give them each their own parameters, and then they can manage everything from there. So yeah, this is something that I've been working with for the last maybe week or two. Like I said, this is a very recent bit of code that I've been writing, so I'm still very much working on it. It's still a work in progress, but I've been testing it out in a couple of plugins I'm working on at the moment. And so far it's been doing pretty well. It's definitely taken a little bit of getting used to since I've been using the value tree state for a few years now. So using anything else, I'm sure would take getting used to. But I think it's going to work. And I also kind of took some risks along the way. So I did some things that maybe are as far away from the JUCE implementation as possible. And the idea there was that if it works out, then that's great. If it doesn't work out, I can gradually kind of go back towards what the JUCE implementation had, because I know that's going to work, and just live with that. And at the very least, even if I don't end up like using this, along the way, I learned a ton about how the value tree state works. So that's been a really great experience for me as well. So in case you want to try out this way of handling plugin state, this is all part of my library. So I have this library that's just basically a bunch of JUCE modules. And the JUCE module that you're looking for is called ChowDSP plugin state. I should mention that some of the code in that library is GPL licensed, but everything that I've been showing today should be BSD licensed. And if it's not, let me know, because that means I did something wrong. So yeah, you should be able to use this code in pretty much any application you would like. And yeah, that's all I've got for today. So if you want to contact me, I'm on the Audio Programmer Discord. I'm on email. I'm on GitHub. So yeah, feel free to contact me anytime.
Fantastic. Thank you so much, Jatin.
No problem. Yeah, thanks for having me as well.
All good. So we have a few questions from Akash. Hey, Akash. And I think you may have talked about this earlier in your talk, but maybe not. So Akash says, one of the annoyances of using the value tree class is that it's notoriously difficult to inspect the contents of the tree when debugging. Is that something that has bothered you, and is that something that you account for in your implementation?
Yeah, I've definitely had that experience as well. I mean, I guess I account for it by not using value trees at all, which I don't know if that's a really accounting for it, but it's just kind of taking a different approach. So yeah, I don't really use value trees at all in my implementation, but kind of as I showed at the end there, I've started setting things up where I basically have like these nested structs that have all of my parameters in them. And I've found so far that that's a pretty neat way to debug things, just because I can say, hey, I have, all of my parameters, or I have, just my processor one parameters or whatever, and then I can sort of fiddle through them in the debugger, just as like a sort of the debugger tree that I'm used to looking at. And that's worked out pretty well so far.
Great. And a nice compliment from Ismar, who says, thanks, Justin, super clear. Always glad to improve my understanding of concurrent programming.
Oh, thank you. Yeah. Yeah, I had to learn a lot about that as I was working through this as well, because there was a lot of things that were kind of new to me, and I was just, reading on the JUCE forum and reading in other, C++ blogs and things, trying to figure out what I should do.
Fantastic. Okay, any other questions? I will give a few seconds for anybody else to ask any questions. Okay, doesn't look like anybody. Looks like everybody's clear. Great stuff.
Cool.
Cool. Any thoughts, Rachel?
Yeah, just it was very clear presentation. Really enjoyed it.
Thanks.
So
Yeah.
thank you. I think
Cool.
I'll need to go back through it, fully understand everything.
Yeah, me too.
But
Yeah, that's
glad
mainly
we
why I
got
put the
it
slides up
recorded.
there. Yeah, I figured there'd probably be some things that need a second or third look. Yeah, it's a lot of stuff, definitely.
Nice.
Cool. So, yes, before we go, would like just to once again thank our sponsors, Focusrite and Sonox, for sponsoring the audio programmer meetup. Without you, this meetup wouldn't be possible. And thank you to the speakers, Daniel and Justin, and thanks to everybody who tuned in.
Thanks for having us. And thanks
Yeah,
for
thank you.
organizing, Josh and Rachel.
Yes. Oh, there was one more question for Akash. Where does the reflection come into play?
Yeah, so the reflection is kind of important for basically managing the struct of parameters and doing things with that as a whole. So like you might have seen in the code in a couple places, there's this function called like do for all parameters or something like that. And basically the idea there is that you have to loop through a struct of parameters. And then if you see a parameter, you say, okay, I'm gonna do something to that parameter. Or if you see a struct, you say, okay, now I need to loop through that struct. And so it's kind of this recursive thing. And C++ as it in sort of the standard form doesn't really have a way to loop through a struct. So that's where the boost PFR library was helpful for doing things like that. And that's kind of the same way that the same method that's used to save and load the plugin state and things like that. Yeah, so the reflection is pretty important for kind of managing all that stuff and hopefully hiding it away so you don't have to think about it, and you can just make your structs and put structs inside structs and let it get taken care of. But yeah, it's certainly not at the point where it all just works yet. There's a lot of things that I'm still trying to figure out.
Great. Yes. So, yeah, thanks to everybody who tuned in. We are back in January. So even though we have the holidays, our next meetup is going to be right afterwards. We're going to keep this thing going. So, next date is the 10th of January. So join us. We have some, we already have some exciting guests lined up and some panels as well. So some exciting stuff coming up. A lot of really interesting advancements that are happening in the world of AI and in the world of audio, and yeah, a lot of great stuff to talk about for the new year. It's going to be a great year for software development, and I think for software development in general. Really exciting. So, and with that, once again, thank you to the speakers, Daniel and Jatin, and thank you to Rachel for co-hosting as well. And we hope
Thanks,
that you
George.
have a happy holiday, and we hope to see you on the Audio Programmer Discord or see you next month. And with that, we will let you go. Everybody have a great day, and we will see you in 2023. That's the first time I've officially said that. So see you next year.
See you soon, Josh. Thanks again. See you soon, folks.
All right, we are offline.